welcome here, Gabriel. It's a true
much.
pleasure to have you on the show. And I remember the first time I met you, you were actually in Paltorion, and your cousin Daniel had invited you, and you showed off your Furhat robot. And I think everyone was really, really impressed with how we can actually have all these kind of facial expressions already working today in a robot like that. And I think that's especially true in a situation that we have today in Corona times, where everyone is lacking the type of social interactions you have physically, but not really getting when you work remotely all the time. I think it's especially interesting of being able to have these kind of social interactions in these times. Wouldn't you agree, Gabriel?
Yeah, exactly. I think that's what we all miss in all these Zoom meetings we're having. Yeah. We feel that there's something missing. And I think that's the motivation for Furhat that you were talking about, is sort of how can we create a physical interaction, a physical meeting with a machine in the same way we have physical meeting with each other, a face-to-face meeting. Yeah. And everyone knows intuitively that we prefer that. We wouldn't go out and have a beer on a Friday over Zoom, but we want to meet face-to-face.
We actually tried that once, but it didn't really work.
Okay. No, I can understand that. And actually, then it's the same thing with a machine, that having an interaction with a machine that has a physical presence and you have a face-to-face interaction is something very different from having it with either just a voice that you have, like in a smart speaker, or a virtual avatar on a screen. It's something different.
And you as a professor as well, I mean, you have PhD students, you have courses you have to teach, etc. And I guess it's all being done remotely these days. And it's Zoom-based, right? Or?
Yeah, exactly. And I guess it's the same thing there, that sort of it's very hard, especially if you have many people you're talking to also, to keep track of are people falling asleep or what's happening here.
You can't read their facial
No, exactly. And if we have a physical meeting, we can very quickly glance and see what's happening, and people are reacting to what you're saying and so on. So yeah, it's the same thing there. Of course, it's
Have you ever thought about using Furhat in some way for your teaching or for PhD students or whatnot? Or is it...
Yeah, I mean, for education, I think that's obviously a use case, but also there is an interesting use case of robots in general, this telepresence, which means that you have, if I was able to come here, I could put Furhat here, and then I could sit at home.
You should have brought the Furhat here.
Yeah,
I didn't think about that. But okay.
So I could have Furhat sitting here, and then I could sit at my home, and then I could connect to the Furhat, and whatever I say would come through Furhat lips, and wherever
Does it
I look,
work in more or less real time, so you could actually.
Yeah, exactly. You can add the lip sync. So you process the speech and you add lip sync in real time on top of the speech. And if I look at you, Furhat would look at you, and so on. So I would sort of, to me, it would be like sitting here, and for you, it would be like me sitting here.
I think we need to have a part 2 of this whole interview, but we will invite Furhat.
Yeah,
that would be super.
That would be
cool.
very interesting. Yeah.
Yeah, it would be awesome. And I guess a lot of people are now wondering, who is Gabriel and what is Furhat and what are you all speaking about? But perhaps we should start simply, who is Gabriel? How would you describe your background and your personality?
Yeah, so right now I'm working both as a professor at KTH. I'm working on conversational systems that can interact through conversation with people, and human-robot interaction. On the one hand, and then on the other hand, I'm a co-founder and chief scientist at Furhat Robotics that is developing this Furhat robot that we have been talking about.
And how would you describe a conversational system?
So that's a system that tries to have a conversation with humans in the same way that we interact with each other, or similar to that, at least. Which could be anything. It could be more of a chatbot that is more sort of social interaction, but it could also be something talking, discussing about teaching you a new language, for example.
Which one do you think are the most famous conversational cases out there now. I've seen a couple ordering pizza,
exactly.
fun on YouTube.
I mean,
which one do you regard as the one we should all find on YouTube after this?
I don't know. You can watch the videos of Furhat, of course, but I think
good.
the one that people are mostly used to is having a smart speaker or a voice assistant,
right.
And it's not so much of a conversation. Of course, you ask it a question and you get an answer, and then nothing more happens.
So that's generation one that we experience.
Yeah, exactly. But of course, the interesting things happens when you start to build on that and start to ask the next thing and so on. Historically, maybe the most famous conversational system was ELISA,
right?
That was built in the 60s, and where Joseph Weizenbaum was the creator who tried to emulate a psychotherapist by very simple means.
I think ELISA is a very interesting topic of discussion, and perhaps we should just briefly skim over it to not jump too much back and forth, but then get back a bit about your background.
We do this first and go to ELISA second, because this is a good topic.
Yeah, but I hate going back and forth.
Okay, you decide. It's okay.
So should we just have a very quick introduction to what ELISA is, because it's one of the most, I think, famous AI systems, and one of the first ones as well in the 60s. And correct me if I'm wrong, but basically they tried to build like a therapist, and it was not machine learning based at all, completely programmed.
Yeah.
And the only thing it did was more or less throw back the same question or the thing you said back as a question again.
Yeah.
Right.
And actually, it's quite an interesting sort of story behind it, because it goes back to the Turing test. So Alan Turing had this idea he asked himself, what is intelligence? And the answer was that if you have a chat with someone over a terminal and you can't know whether it's a human or a computer, you have managed to create an intelligence. And actually, the reason Weizenbaum created ELISA was to prove that Alan Turing was wrong. In the sense that you can create a machine which has a conversation without intelligence.
As a therapist.
So if you do it in a smart way. So he just sort of, if you said, I have problems with my mother, it would just pick out mother and say, tell me more about your mother.
Yeah.
And you could actually have a conversation. And it turned out that people really liked ELISA. And there are sort of anecdotes of his secretary really wanting to continue this conversation with ELISA and not being disturbed, because it was such an interesting conversation.
Yeah, either it says something about humans, or
a good listener.
Yeah, exactly.
Or it says something about how psychologists work today.
Yes, I had many jokes on this. Oh, it sounds like a politician. I don't know.
I mean, it's called something special.
Not a straight answer, just another question.
It's called something like Rogerian type of
exactly.
psychology or something.
It's a special style of where you basically just echo back what you hear and rephrase it a bit.
Well, whatever works. But the Turing test, I think it's certainly something we should talk more about, and if this is a good test or not. But before we do that, perhaps just speaking a bit more, you have been in KTH for quite some time, right?
Yeah, about 20 years now. Yeah.
And what did you do before that? I think you actually went to Linköping as well, which is my university as well.
I studied cognitive science there. So that's, for those who don't know, it's a mix of computer science and AI and psychology and linguistics. So trying to bridge these things and trying to understand both how human cognition works and how we can build cognition in machines.
And cognition, can you try to describe that? What do you mean with cognition?
I guess that's similar to what we say when we mean intelligence, but in psychology, cognition refers to like perception, memory, decision making. So it's sort of a psychological term for these kind of more sort of higher level function, not emotions perhaps, but rather sort of the more reasoning and sort of the logical side of humans.
IBM tried to use that they work with cognitive intelligence or something instead.
I don't know.
We had Patrick Couch here from IBM, and I guess it's branding as well.
Yeah,
to find their own hype word.
You could say thinking.
Yeah, thinking. Thinking is better.
Yeah. But more human type of thinking, or
I guess some people talk about animal cognition as well.
Okay.
So I mean, animals have perception and memory and so on. They don't have language in the same way that we have. Language is a very important aspect of cognition, of course. So that's why I become sort of interested in this this area of sort of how language works. Yeah.
But in academia, to use the term cognition, which faculties do you belong to where this comes very natural to say cognition instead of intelligence?
I mean, I think it's mainly in psychology or in the field of cognitive science, where you try to bridge that with language and with AI and computer science.
Okay.
That's where you would use the term cognition. Yeah.
And I know you're like the president of one of the ACL special interest groups, etc. So you've been very successful in the academic sector here. But how would you describe your field of research right now in KTH?
Yeah, so as I said, I work on conversational system, but that's a very sort of broad topic. So I'm trying to pinpoint certain things that I think are most interesting when it comes to conversational systems. So one of the things is partly how the role of the face in the conversation and how we use that to signal different things. So that's where the robot comes in, and also, of course. Yeah. And one of the aspects that I find very interesting is, for example, turn taking in conversation, and we can model that.
So more moving to a dialogue system.
Yeah, exactly. So in a chatbot, turn taking is not an issue because you type what you want to say and you hit enter. And then turn passes to the other person. But in a conversation, it doesn't work like that. We don't have an enter key. So
you wish you had an enter key for me. He wants an enter key for me.
Being able to interrupt and not to interrupt is a function I wish we had a button for. But
no. Sometimes you actually do this. If you have troubles sort of arguing back and forth, you say, "Okay, I have the orange. Now I'm holding the orange, so I'm the one."
These techniques actually in that can be used even.
But that typically is not something we have. So we somehow manage to pass the turn in conversation in a very sophisticated, subtle way with extreme precise timing also. So if you look at human conversation, you find that the sort of modal, the mean response time from one person to the next is around 200 milliseconds. So it's really quick.
It does differ between people, though.
It's a difference between cultures.
I was thinking if this is a gene thing or if this function is broken, can it be?
No, there are a lot of differences, and if you look at children, there is a difference and so on. But I'm just talking about some kind of average. Of course. And it really means that partly we have to understand when we can do this, because maybe you just make a pause and have to think about what to say. I can't just jump in and talk. I understand that you want more time. But a computer doesn't understand that today. So it will just barge in and interrupt you. If I, for example, talk to my smart speaker and I say, can you play? And then I can't think of the name of the song. It will interrupt me and say, sorry, I don't understand that. Right. And a human wouldn't do that. So that's what we want to see. Can we build a system that can understand when it's appropriate to take the turn and not? And can it do it with this kind of precise timing that humans can achieve?
And that includes both listening to the audio or text, but also watching the face in the play?
Yeah, so the face plays a role. So sometimes we include the face and sometimes not. But it's partly the words we're saying, but it's partly the tone of our voice. Right. So the melody of our voice. So if we have like a more flat pitch, it typically signals that we want to continue talking. Whereas if we have a rising pitch or a falling pitch, we might pass the turn. Yeah. And then if you add the face, then if I'm thinking about what to say, I typically look down a bit to think what to say. And then when I'm finished, I look up at you. Right. So we combine all these different things. And that's where machine learning comes in. Because then you can use machine learning to try to combine these things and identify that.
Multimodal kind of fashion.
Exactly.
Yeah, very interesting field of research. I think that is a lot of need for improving the current quality, I would say, in a lot of AI systems. Right?
So, and what was the idea and what's the background to starting up and founding a company?
So we started back in, I think it's like 8 years or so as a research project, and we wanted to look at how you can have multi-party interaction with these systems. So you
multi-party means?
It means that what we have now. So it's not just
multi-party.
Yeah, exactly. Yeah. So it's not
several
just two
people.
So, but because typically in a conversational system, you have the system and one user. So it's a two-party conversation. What if you want to have several people talking to the system? So imagine a system at a train station and you want to buy tickets and you are two people talking to the system at the same time. How would the system manage that conversation? And again, the turn taking becomes more complex and everything becomes more complex. But one of the things is that it's very hard to have a multi-party interaction with an animated agent on a display, because it's very hard to know who the agent is addressing. If it looks straight into the camera, so to speak, everyone will feel like they are being addressed.
Yes.
It's like a newsreader on TV in the sofa where everyone in the living room thinks, "Oh, he was looking at me." But you don't have that with a robot or a person. You know who I'm looking at. So we wanted to see, can you build, if you take this avatar in 3D, maybe you can have this kind of multi-part interaction in a much more natural way with an agent. And that's somewhere there where the idea came to try to take the animated agent and project it on a 3D face. So first we projected it on the front, but then the agent can't move the head. So you have to project it from the back, so it can actually move the head.
Do we have a video of this, Goran, or is it something we can put up?
So that clearly became extremely effective once you did that, because you could have this eye contact where it really feels, "Ooh, it's looking at me," and you have the physical presence that we were talking about in the beginning. So you have this feeling of talking to someone in the same room, which is very hard to explain why that is so different, but it's just very different. And
I think it's really a smart idea. I remember this when the first time I saw this. It is really fascinating and sometimes a bit scary as well to see the facial expressions from the robot and the eye contact and everything.
Yeah, exactly. And of course, since it's animated, if you compare to other robots, it's partly much more expressive and detailed, but it's also a cheaper solution and much more flexible. So you can project different faces and different animations. And should it look like a man or a woman or a child or a creature?
And if I'm not incorrect, you can basically upload your own like persona to it. And
you can do that. To some, as you can see here, the mask is actually detachable. So to some, for me, it works fairly well to project my face on it, and it looks kind of like me. But if the shape doesn't fit too well, it will not really look like you. But then you can actually so we were actually asked at one point to make a replica of Mikael Damberg for some event.
The politician?
Exactly, in Visby. So we did that. So we made a replica mask of him and an animation.
And could you both do it like an AI, but also you can, what is it called, telematically be at another place and use
that you could. So for this telepresence thing, that would be an excellent thing. Of course. Yeah, exactly. In that case, it was not. We didn't have time to develop any sort of replicate him as a person, sort of more his appearance. But it's a very flexible solution in that way, that you can project different faces and so on. And that was the sort of, once we did that and we displayed it at the London Science Museum, because there was an exhibition about robot projects around Europe, and our robot was the only one you could talk to. So you could hear the voice of the robot all over the museum, and we got BBC and a lot of different sort of, everyone was very interested in this.
The robot that did the most in some ways. Yeah,
in some sense, it drew most attention. So that's where people started to ask, so sort of, oh, can you buy this? And no, we are just researchers, you can't buy it. But that's where the idea came to, maybe we should make a product out of this, because it seems like people are very interested in this.
So how is that? Do you have a product ready for sale today, or?
Yeah, absolutely. And so we have, this is like a platform, you could say. So it doesn't come really with intelligence sort of for a specific application built in, but it's a platform on which you can build different applications. So we have a lot of researchers or research institutes in bigger companies. We sold actually one of the first customers was Disney Research. Yeah. Oh. So they bought one and experimenting with how you could do human-robot interaction.
For like Disney World kind of applications or what? Or?
Yeah, so they actually have a whole department doing research on human-robot interaction, I think especially for Disney World. And
super cool.
Yeah, and they of course those robots are mostly teleoperated and they are not autonomous. But of course they are interested in how to make it more autonomous.
And where do we see the first live applications or use cases, or what has been so far when you have sold it? Or
so the more sort of actual sort of applications, we had one collaboration with Deutsche Bahn. So we had Furhat at Berlin train station and Tokyo train station and Frankfurt airport, answering questions like where is my gate, or is my flight delayed, where can I find the bathroom, and so on. So that was it didn't sort of, or haven't yet at least, sort of scaled up from that, but it was really cool to see that we could use it live, and I think they were quite it turned out to work quite well.
I think that's an awesome and interesting application. Could we just at least briefly go a bit into the technical parts of that? And if we take this example of you have a social robot, it's some kind of physical presence as well, and you can go up to it. I've seen, I think, some video for that in the Berlin train station or whatever it was. And then people come up and they start, being really fascinated with, something that actually interacts with them. You can see it actually reacts to the people coming up there. But so one thing is basically the social interactions and the facial expressions and how it understands who to speak to and everything, and turn taking. But if we just, take the normal kind of chatbot kind of question of when does my train to Frankfurt leave? How do you make that work? How do you...
So this kind of applications where you have this answering, it's sort of a more task-oriented, limited domain dialogue. So it's not supposed to talk about anything, but it's supposed to talk about things that are relevant for the train station. So typically what you do is that you try to define different, what we call intents from users. So different types of things you might say. And then as a developer, you add examples of every way to say, is my flight delayed? So there are many ways of saying that. So you provide examples, and then you basically try to classify whatever the user says as being one of these intents. And then we have a state chart mechanism for knowing in which context you are saying this, basically in the dialogue, and move forward.
So would it be a naive and crude way to say that you have like templates of what to reply with, and you fill that in with facts?
With facts and information. Yeah, exactly. So it's at the core, it's sort of fairly rule-based, and then you use sort of machine learning for the more classification tasks to map that into what kind of action the user does and know what to do next.
And how do you understand the sound and make that into text in that way? Do you have your own developed system?
No, it's not ours. We're relying on Google there. Using their speech to text. But we try to do some more intelligent things there. You can prime the recognizer. So depending on which state in the interaction you're in, you can, for example, listen extra carefully for certain words and so on. Right. So there are some of these things going on also.
And where does the other tech come in, like the turn taking, facial recognitions, or making it more
exactly. So there are many bits and pieces, and some of the things are developed by others where we use in this platform, and some things we develop ourselves. So for example, when it comes to face tracking, we are using a face detection software that uses deep learning that is not developed by us, but then we add a face tracking system on top of that, because you for every frame you can see faces, but you have to keep track of who is who when they move around. So that's
to keep the conversation.
Yeah, you need to know it's the same person that is moving, and it's sort of not a new person popping up somewhere, and that can be challenging if there are many people moving around
in a train station. I can.
Yeah, and that's the kind of chaotic situations that we are sort of trying to deal with. So that's another place where sort of this kind of machine learning comes into the picture. Of course, is to sort of track people from a vision perspective.
So you have the speech to text part you need to do. You have some kind of finding a proper response with the actual facts that you need to do. You need to, of course, go back to speech and text to speech kind of
exactly.
Them. And I guess you use Google and off the shelf techniques for that.
Yeah.
And then you need to do the visual kind of face tracking and identifying people and where they are. But then you also need to have, in your situation, some way to determine what the facial expression should be as well, right?
Yeah, we can detect a series of facial expressions, but
I'm thinking more of the generation of it. I mean,
the generation of it, yeah, exactly. Exactly. So that's also something that we try to some extent to generate at appropriate places, depending on what's happening in the system. So, for example, if the robot is listening, and the user starts to speak, we might want to raise the eyebrows, for example. So we try to map certain facial expressions to other events that is happening in the system that sort of signals to the user what is going on. And that's something you can do with this kind of face. Rather than lighting up a lamp saying, I'm listening or something, you can try to express this in the face in the same way that we do. It
becomes a bit more natural type of discussion than.
Yeah, exactly. It feels more like a natural conversation. And that's the motivation, actually. I mean, some people ask, why do you have a human-like robot at all? And this is one of the motivations, is that we already know how to read these signals. So we can apply it directly to the robot.
And how do you train that? Is that something that you basically have a rule-based system to train up? Or
that is currently rule-based. We're looking into more data-driven approaches there also. This is also connected to, I have a lot of colleagues also at KTH who is doing a lot of very interesting research related to this, how you can go sort of directly from the text that the robot is speaking to automatically generate appropriate expressions or gestures. And you can do that, of course, in a data-driven way if you have videos of people talking and so on. So there's a lot of interesting things going on in the research. And of course, it has to be mature enough to put in a product. So that's always the sort of the challenge of what you can do a lot of interesting experiments in the research lab, but what works well enough to actually put in a product, that's a different thing.
This is actually very important.
Classical go to production,
Yes.
deploy, commit to deploy. We talk.
Yeah, and then you have processing constraints. Everything has to run on the robot, so we have to sort of choose which things are sort of are practical.
I think, should we jump to that topic direct, because I think it's so important and it's something that
it's a super important topic, and it's very interesting to see the angle from a human-like robotics. What does it
very
mean to
concrete kind of example?
Concrete go to production. Yeah, let's go there.
Okay, so Furhat has this kind of amazing product already. It works and it's been deployed, and you actually put it in production, which is more than I think a lot of people actually have, especially when it comes to robotics. And not even going to the Boston Dynamics. Okay, stop. Anyway, if we just speak about this, I mean, you're primarily and initially a researcher, academic researcher, and you also now have an entrepreneur kind of side to yourself and actually have worked a lot with the challenges of moving something to production. But if you were to try to think, what are the top challenges, you would say, in taking a research idea, something you just published, or are working with right now from PhD students or whatnot, and actually putting that into a product that can be used in practice. What would you say the top challenges are?
Yeah, that's a tough question. I think that one problem when it comes to, there are many problems, of course. One problem when it comes to more machine learning or data-driven methods is that you can do something that works well in the lab where you have a limited data set and a limited problem, and that's how you approach these things typically. You say that, okay, I build in all these limiting things and sort of simplifying assumptions to make my experiment run. But then if you put it in a platform like Furhat, it has to work for all these different use cases. And as I said, the robot at the airport is just one application. We have other applications where the robot does job interviews or is telling stories or something. And how can that model be general enough for all these different use cases? Well, often it can't. So then it's sort of a question, maybe you would need different models for different use cases and so on. So just because you have something running in the lab, it doesn't mean that it's general enough to put in a platform. I think that's one of the maybe major limitations. And another, of course, is processing power and so on. That we run most things, everything actually except the speech recognition part, the speech to text is run on the robot. So the face tracking and everything is run on the robot. And of course, there is some limit to what you can do on the robot. So that's also a practical limitation. I think maybe these are two of the things. It has to be robust enough, basically, for work in all these different use cases and with real users in real scenarios.
And perhaps you're an exception, or you are an exception, I would say, to what the common scenario is, because I think there's a lot of company that tries to make use of AI in different ways, and they usually fail. And they build a prototype that works really well. And they can demonstrate some kind of value, saying, if we just put this in production, it will generate this much value for this company in doing what. But then people fail in doing that. And there is this term called the prototype graveyard that is starting to gain some traction, I think, which is kind of sad. But we know the big tech giants, they're certainly succeeding with it, and they have so much AI in production in different products and services. So it is possible. It's just that people fail all the time. But you didn't fail. And
no, not yet.
Perhaps it's just because you're knowledgeable enough. But if you were to just reason or try to guess about why so many people fail about putting things in production,
I don't think that it's their fault. I mean, it is extremely hard to know beforehand what will work and what people. I mean, also as in general, I guess if you start a company, what do people need and what? I mean, I can't even predict my own needs. So sometimes you read about this new gadget and you think that I would want that kind of thing, a new camera or something, and you buy it. And you never use it, but you thought you would use it. So you can't even predict your own sort of usage. And then other things like the iPad. When I read about it, I thought, this is stupid. Why would I need an iPad? I have a laptop. But I bought one anyway, and then I started to use it all the time. So I can't predict my own sort of usage. How could I predict other people's needs? So I think it's extremely hard before you actually try it out in real life. It's extremely hard to predict and to build a business case, I guess.
But how do you see? Because I to some degree see you as in a unique position to understand the core dimensions, what needs to happen to go to production here, and you might. I working a lot in the large enterprise where the pilot graveyard or the prototype graveyard is very prevalent. It has something to do with also that people try something for the wrong reasons, right? They want to show something off, they want to show their cutting edge, but they have not really thought through or understood all the different bits and pieces that needs to go together. I would assume, and that's my question, that you probably have a better grasp than most about the whole process here, that what needs to happen. I think that could be people don't really understand how far you need to take it to go to production.
Yeah,
what do you think?
That's true. I mean, one thing that sort of saves us a bit here is that we are building a platform that we are initially especially selling to researchers who are a little bit more forgiving, that we are at an early stage. I mean, the first prototype that we sold to Disney was extremely prototypey, but they were okay with that, and because it was a research lab. And also the fact that we are doing it as a platform, because we don't know yet why you would need a social robot. We have to explore this. And the way to explore it is to create a platform that different people can try out and explore different applications together with us. And some of these will certainly or have already failed. So there is sort of a prototype graveyard already there in all the things that people have used Furhat for. But I think that's fine, because we have to explore what to
but
use
isn't
it
that
for.
also
And that's also a difference, I would say, from other. There are several examples of sort of failed social robots project where they already decided from the start what the robot should be used for, and it turned out it wasn't a viable sort of use case, and that's why it failed.
And I think that you said it yourself now. That was exactly the point, that you were enlightened enough to understand we don't really know. We're humble, so we make it a platform, which is genius, depending on where the maturity of this whole phenomena is. And I think if you go, as an example, as you highlighted, someone has already, we think we know this. That's another graveyard, that you think you know, but you don't really have the data to back it up.
Yeah, sure. I mean, it's a challenge to build a platform, of course, as you, because it's very broad and you can't sort of build in a lot of assumptions into the platform. We talked about these machine learning models. You can't put the model in there because it depends on the use case. So there's a lot of problems there. But at the same time, you have the benefit of being open to exploration.
But was this a huge discussion? Like, I can imagine.
Yeah, sure.
Thinking about this.
Very, very early on, we had this discussion because everyone that came into the project early on said, you can't build a platform because you have to decide what the robot is for. You have to build a robot. You have to build a robot for this application or decide what the application is. And I think that's. But we wanted to build a platform.
But it's hard for startups, and so many startups fail, both in Sweden and around the world. And one thing you have to think about, and something we've spoken quite a lot about, is what should the go-to-market strategy be in some way? And we have, one person that we often bring up, which is Elon Musk, which has a bit of a different go-to-market strategy, I think, than many people. If you take Tesla, for example, he perhaps targets like power users or people that really want fast cars first, which is kind of weird, I think, when you start thinking about it. But it was really smart in some way, and then turned towards the mass market in a later point in time when you have the finances to actually do that in some way. Did you have a specific way of, how to go to market? Did you think about the strategy for that?
In a sense, it's similar to that. Currently, the robot is very expensive. So it means that it's not an end consumer product. You couldn't put it in the home of an elderly person to because it wouldn't be. So we decided that this is an expensive product for initially doing exploration and research sort of and development.
So actually a very clear understanding for who you think will be the first wave buying this type of research.
And then once we have sort of passed this exploration phase and starting to see what the robot is actually good for, what kind of use cases, then you can start to think about how can you actually cut the price.
And also narrow down then the use case application and then go on cost for this.
Exactly. So I think that's a problem that many of developers of social robots have faced, is that it's so hard. If you want to make an end consumer product, people are used to be able to buy a laptop for 3,000 crowns, nothing. And if you want to create a social robots that costs 30,000, nobody will buy it. So it's very hard to start addressing end users.
That's very interesting.
Yeah, I wish more people had like a good way to really go to market and know all the challenges. And I think you enlightened a lot of people now, what the problems are. Still, I must say, it sounds like it was easy for you in some way.
No, it was not.
How many years was this in the making from being a research project to the product?
Well, it has very gradually grown, I would say, from that. So the first research prototype was perhaps built around 2011 or so. We started the company in 2014, and immediately, because we had a request from Disney to buy one of these.
So Disney was the first customer.
Yes. Exactly.
Okay. Always good to have a customer lined up inside the company.
Yeah, I mean, it was just buying one research unit, but still, it was very nice, of course, to have them interested in this, and it looked, of course, it's a very nice customer to have. So, and then there were a lot of universities and so on who were also interested in buying it. But at that stage, it was still very sort of much of a prototype. And then as we got more customers and more understanding of it, and we got some funding and so on, we could gradually make it more and more as a professional product. So it has really grown sort of more organically.
But also another angle on this go to production and be successful. Would you want to elaborate a little bit on the Furhat team? What's the team behind this? And that's very interesting, of course, to understand also.
Yeah. So it's a team. We as founders, we were three from me and Samer Al-Mubayed, who is now the CEO. This was one of his sort of project as a PhD student at KTH, and his supervisor Jonas and me. So we were three people working together on this and started the company. And now Samer is the only one working full time on Furhat, and me and Jonas are still working as professors also at KTH. And then the team grew organically now, so we have, of course, an engineering team working on the software platform and working on the hardware, and of course sales team and so on, looking at different use cases and selling it to these different researchers around.
And was it easy for you to see sort of what fundamental skills you needed for the different pieces? I mean, like because you've been researching it, it's you knew your problems, so I guess you needed. Or was that hard to pick?
Yeah, a bit perhaps. Again, I think we have grown organically when we have seen needs, but of course it's hard to balance how much engineering should you have and how much sort of should you push for sales and so on.
But did you do some fundraising as well, or did you?
We did. So we have investors. One in England, Balderton, and one in Singapore, Qualcomm.
Okay, interesting. Cool. And perhaps just to close this theme, and I'm eager to move into some other things. But if you were to redo the whole process today, what would you have done differently to make Furhat as successful as possible?
I think that's extremely hard to say, because it's so easy to look back in hindsight. And
2020 vision.
But I mean, that's the whole thing, that you can't do that and you have to grow. So I think in a sense...
let me rephrase the question. If you were to give some advice to a person that have an awesome idea and they want to build a startup around it, how would you guide them to proceed?
I think this general advice of getting it out there and getting customers very early, which is a common advice, but I think that's extremely important to see that people actually start using what you're building and getting their feedback. I think that's extremely important, to not just sit and develop something and then eventually let someone use it, but and also use it yourself. I mean,
dog fooding.
Yeah, exactly.
But this is a recurrent theme from many angles, right? So how can you shorten the distance for each iteration and get feedback? The whole MVP thinking, or whatever you want to call it. And we've talked about this. Do you want a huge runway? We talked with another friend of ours, and I think it's really important. Because I think we are doing this mistake all the time, not only as a startup, but also in our innovation projects inside a big company. So it's a simple, very basic advice that actually has quite a lot of implications on how you set up the project.
No, exactly. And of course, it's easier when you have this kind of product that you can afford to iterate many times, that we could. For every hardware iteration, we could change things, because early on we worked with 3D printers and stuff, so we could very quickly change things between each iteration and produce it on a very small scale. So if you can afford to do that, I think that's great, to have as many iterations as possible.
Let me move in to another but related topic. So I've struggled to find competitors to Furhat. And if we bring up one, I don't think it is a competitor, but a lot of people have heard about Sophia. It's a robot, I think, that was the first person to become a citizen in Saudi Arabia or something. I'm not sure which country, but that was the first robot to become a citizen. And there's a lot of videos on her, and I think it's from Conversational Robotics. Yeah. and she can do facial expressions as well. And there is a physical presence that she can provide. To start, what's your thoughts about Sophia to start with in general sense?
To start with, I'm not sure it is a competitor in the sense that I'm not sure you can even buy Sophia. Or maybe you can, but it's probably extremely expensive.
Yes.
Please play the video if you can. It's
So that's a difference. We can come back to actual competitors, I think, later. But one of the things, of course, they are trying to build something that sort of is similar to a human and human interaction. But of course, when it comes to the actual hardware, the approach is very different. Of course, this is typical also from if you look at robots from Japan, they often use this. So you have a lot of servo motors in the face and some kind of artificial skin. So it's supposed to look very human-like if you just look at a still build, but still a photo. But once it starts moving, it looks very creepy because it's very hard to match this very human-like appearance with human-like motion using these servo motors and so on. And so apart from the fact that it's very expensive to produce with all these servo motors,
but it's mechanical behind the skin in a way.
Exactly. Which makes it fragile and expensive and so on, and not very flexible. Again, with Furhat, you can project different faces, and this is fixed. So it's I can't really see any argument for why you would want to have this kind of mechanical solution when you can have back projection. I think
exactly. I mean, I think the back projection part that you do is so genius because it actually make it work in a practical way and surprisingly realistic way quickly today.
Yeah, exactly.
Do you think it also says something about the state of robotics in general it's very far behind?
Interesting. I think that's the reason where you come from, because if you look at robots today, and most of them are developed by people who have a background in robotics. We didn't have a background in robotics. We had a background in speech communication and speech technology and natural language processing and so on. So we were sort of more thinking,
how do I get
from a blank slate? Yeah, exactly. And they were thinking, of course, if you're a robotics person and you're asked to build a human face, you start thinking about servos and mechanics. That's where you start. So that's what most people do. I can't really see any motivations for doing that, actually, when it comes to the face of the robot.
We are sliding into first principle, having a clean slate. Really, this is another side pet discussion. There are, when we have several nice interviews and stuff like that, there are some recurring themes. What really works, or what seems to be important. And another one is that whole first principle idea. Once again, something we talked about that Elon Musk has done well, right? To really, how can I rethink the process, or how can I rethink the whole thing from scratch and not build my business model or my engineering idea on an analogy, but rather completely from scratch. So I think that's interesting now, because you come into this topic of robotics, but you're not stuck in the mindset of what it's supposed to be.
No, I think that might definitely help. And and most robots today still, they are either using the servo, or the robot is completely sort of a plastic stiff face, which doesn't have any expressions at all.
So Sophia, for one, she has the physical performance of the robot, which is very lacking, and the servo motors that they have in the face, and she can barely walk at all if possible. She has a lot of lacking skills when it comes to the physical robotics. And then your specialty is also in conversational systems and how you can have turn taking and conversation in a human-like manner. And do you have any knowledge? I'm not sure how much you know about the internal workings of Sophia, or how they do the conversational systems.
Not really. I would say it's very hard to say. I don't think they have published much about that, so it's very hard to read about or understand what they have done. So I don't think it's very sophisticated. I don't think they publish conferences related to conversational systems and so on. Of course, if you look at these videos, all of them are sort of staged conversations.
Right.
So it's I don't know if it has ever been deployed at any real scenario like Frankfurt Airport.
Yeah, exactly.
Exactly.
But probably not.
I would be scared if I saw Sophia at an airport.
Frankfurt Airport.
So I think it's mainly built for stage performances, and of course we get these requests also sometimes to do stage performances. So it's very intriguing with these robots and so on. But it's of course a different thing to build an actual application.
But let me just quickly talk a bit about robotics and the physical, performance of robots in general. And I remember back in 2001, I believe. I went to this Ishkai conference and they had this RoboCup competition. And this is basically a soccer competition for robots playing football or soccer. And they had different leagues, small, the dog size, the Sony Aibo things, and mid-size, and also humanoid, basically two-legged kind of robots trying to play football, but in horrible kind of performance, and they can't do anything. And the performance of them is really not good. But then you have the simulation league where the strategy of playing soccer is amazingly high, much better than humans in being able to plan, but in a simulated environment.
That's the virtual.
But still, they have the goal of 2050 that the world champion of robotic soccer should be able to beat the human world champion in soccer. What do you think about that prediction? Do you think that will happen?
I'm not a robotics person again, so I wouldn't dare to make a prediction about that, actually. But, maybe, I guess it depends on whether the robot... I mean, it sounds quite dangerous, actually, to have a robot on the field playing football, I would say.
I can tell you like a story. They have this mid-sized league, and in that way, they basically have a centralized computer steering all the players in one team. And the way to basically eject the football or hit the football is they have a scuttle wheel that turns really fast. And as soon as you hit the football, it just goes really fast. But then at some point, if they do something wrong, they have the scuttle wheel actually hitting another team player instead. And the team player goes basically flying out of the field, which is it's not a good thing. So if that were to happen with a human, probably not a good solution. Okay, so...
I have a question back a little bit to your KTH. Did you get a grant quite recently?
Yeah, exactly. Some week ago from the Swedish Research Council, Vetenskapsrådet. So that's very nice. It's building on this turn-taking thing, but thinking more broadly about how you can make predictions about the future in a conversation. So, as I said, if you look at two humans talking, and they can switch turn very quickly with, as I said, just like 200 milliseconds. And that's not really possible to do if you would if I would wait for you to stop speaking and then think, what should I say now? And then start to plan that and then start to speak, you would get a very, 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 very long silence. So obviously, while you are talking, I am preparing what I should say next. I'm projecting how your the thing you're saying.
Will it end?
How, not when, just also when, but also how. So I'm projecting the words you are saying and trying to figure out what you will say and how I should respond to that. Otherwise, it would be impossible for me to answer with just 200 milliseconds of silence. So, of course, we do all this sort of subconscious. We don't think about these things, but we have to do them. And these psycholinguists looking at this have been aware of this for a long time, that it has to be this way, but it's very unclear how we do this. And this is what I'm interested in. How can you build a machine that can predict what you will say next?
To be prepared to answer.
To be prepared to answer. That's very interesting from sort of a machine learning perspective, because that's sort of what many of these language models and so on are doing, is to trying to predict what will come next in a sentence, for example.
attention and transformers. And
yeah, exactly. So we have already starting to look at these things. About how early can you predict what a person will do next?
So let me ask the question. So how do you plan to get that done? So what's the techniques that you have thinking about for this grant now?
So we've already started sort of looking at using, for example, looking at only the speech and the prosody to use a recurrent neural network, for example, to predict how likely it is that this person will speak or not in a 3-second window in the future. So we just train it on a lot of conversations. We collect conversations and we train it in conversations to make these predictions. And actually it turned out, and then we gave humans the same task. So we said, okay, we stop here in the conversation. You have to guess who will speak next. And the machine actually did slightly better than humans.
To predict.
So given that someone has stopped speaking, you have to predict who will be the next speaker, which might sound like an easy thing, but it's not. So you can actually train it to do that. But then we also looked at how you can do this using more like a GPT model, GPT-2.
Not 3.
Not 3. We don't have that
not available.
Standing joke.
But then you can actually look at what has happened more earlier on in the conversation and what people have said before to make these kind of predictions even better. And then we want to combine both these sort of more the words, the language, and the acoustic part. And if you combine these, you can make sort of even better predictions about.
So not using text directly, but sound, audio directly, or
both of them together. Okay. So we're combining, and maybe gaze also, to make predictions about the future. And I think that sort of relates to a lot of theories about what really how we as humans in general, how intelligence works. It is a lot about predictions and trying to predict what will happen next. It's not just in a conversation, but in general, we always try to predict what will happen.
So sound and text, are you going to use like video and facial expressions as well?
Yeah, not to start with perhaps, but definitely eventually, and use these different...
So I'm just curious, how is the goal of the research presented, like the value proposition, so to speak?
The value proposition is basic. I mean, that's why it's good to have also from a research perspective to be able to point at Furhat and say, okay, we have this product and I know what the problems are. We run into them all the time, and I can motivate why we need what things we need to improve. And I know things like, for example, turn taking are things that we run into, and we need better models to have a more fluent interaction.
So ultimately, a more fluent, natural conversation, even multi-party.
Exactly. So more closer and closer to human interaction. Yeah, exactly. That's the value proposition. Yeah.
And who in the industry is most interested in this? Because there's of course tons of different types of use cases for this. But where do you see this next level starts to happen first?
Yeah, exactly. I'm missing this part a bit in general. I mean, if you look at the big ones like Google and so on, and you look at these smart speakers and chatbots and so on, they are mostly thinking about what the system should say or type, but not so much about how to create a fluent interaction. And the interaction with the smart speaker is not very fluent.
But jump into that discussion, because there are a number of recent models published by Facebook and Google, like the Blender system and the MENA system, that are these huge transformer models, with billion on parameters and trained on all the conversation from Facebook and Google and whatnot, and can at least produce a set of like textual dialogues that seems rather human, wouldn't you say? Or
in some sense, yes. I mean, the general approach there is to build what they call open domain systems. So you scrape the internet for all kinds of dialogues you can find, and then you just train a model that tries to mimic this And for that, you can build a certain type of dialogue. But the problem is that what if you want to do something where there is an activity going on, like me going to the airport,
there's
asking about information. There's a purpose with this interaction.
Not just general
No,
bullshit.
exactly. Then you can't really use this system, not at least directly. You have to do something more for it to have some knowledge about this specific domain. I mean, they can have general knowledge, like who's the president.
But not like real-time facts.
Not real-time facts. And it's also hard to have let's say that you and me would plan a trip to Paris or something. So if I would ask Mina, can we plan a trip to Paris? It would probably say something sensible. Yes, sure, do that. And then I start saying things and it will say something, but it will very quickly lose sense of what is our activity, what have we committed to so far, and what is our current plan. All these things will be lost because that's not really what it's doing. It's on a deeper level, it's not really doing anything. It's only providing sort of sensible answers to...
It sounds like a GPT-3 in many ways.
Right? And I'm glad to hear that.
It's not really...
we are cutting GPT-3. All right,
it's not really doing anything.
It's not doing anything. It's just cool.
On a surface level, it seems cool to be doing something, and it is super cool, and it is
impressive.
If you want
impressive,
if you want to emulate that kind of sort of initial interaction between two people at a bar,
but here we have
you can do that.
But here we have a proper use case application. We want to do something. We want it to be meaningful to provide an outcome. So what's missing, right? What is it that you want to work on? What is the thing that you need to add to these systems, in your opinion?
So I think, unfortunately, this kind of end-to-end approach is very hard to apply.
It's generalist one.
If you just give it lots of dialogue data, it's not going to be able to do these kind of things. So you have to break it down and say
more
that,
narrow.
and say that, okay, we have these different components, and certain parts you can use deep learning and train and so on, but other parts you can't yet do that.
You don't think you can inject like facts that comes in through a different channel somehow?
You could, but then it's also a little bit hard to find all that data you would need. So if you want to build a robot standing at the train station, answering questions, where would you get that data?
Connected to the data timetable, like the schedule. I mean, like there's domain data here, of course.
Exactly. There's domain data. So you need dialogue data connected to domain data. And most conversations have some kind of sort of background or setting for why we are talking. But if you just find a conversation on the internet, there is no information about that. Why were these people having this conversation? The
purpose bit is lost.
Exactly. The whole dialogue is actually conditioned on these purposes and so on. But you don't know that when you're scraping this data. So you can't really train the model sort of conditioned on these things.
So how can we improve the science and the research being done in this field to move towards more like usable
purpose
applications in that field?
There is a lot of work being done where you try to combine these approaches, and of course you can collect data to some extent in a limited domain and where you have control over these things. But either you try to do that, which some people are doing, or you try to break the system, sort of try not maybe to do everything end to end, but try to
compartmentalize
in different components. And I guess that's where we will be mostly going, I think, with Furhat, is still to look at it as different sort of components.
Do you think there is a lack of a big, commonly used data set like ImageNet, but for conversational systems that have that component in it? Or?
I think there are, but I think it's very hard to... There are these data sets and there are challenges and so on, similar
even with real-time data being like needed?
Not with some kind of data. There is, for example, a system that can answer questions about Wikipedia and so on, where you have the data Wikipedia, but still that would be limited to talking about Wikipedia. It's very hard to get away from the fact that it costs a lot to put together these data sets, and it's still limited to that domain.
Isn't the problem really you need to train them on some piece of static data in some way that you have, and then being able to connect it to dynamic data sets?
Exactly. So let's say an example here. So we are actually having a human standing there at the airport answering all the questions. We record all the conversations, and when we train a model on this, so it can actually act as this human. But what happens when the information that the human was talking about changes? Then all the conversation would change. And do we have to re-record all these conversations? So again, you have to sort of separate this somehow.
But I hear between the line here that you also think there's, don't be too dogmatic. Everything should be machine learning. Actually, think carefully. When is business rule systems quite useful, right? And when is that what I'm hearing?
Absolutely, I think so. And I mean, you should look at machine learning as yet another tool.
Yes,
that is sometimes very useful. And probably the more we develop, the more things it can do with less data and so on. So it becomes more and more useful. But at every point, you should, of course, ask yourself whether it's useful now for your problem right now.
And to a reasonable cost as well.
Yeah, exactly. And is it possible to get data for this problem? And all these practical questions.
What's the rule? Make it the simple. There's a nice say. Go for the simple solution.
Yeah, the Occam's razor.
Occam's razor, and where, by the way, not everybody loves the Occam razor.
Yes, well, I do. But
do you like the Occam's razor? You think it's correct?
Yeah, on a very general level, I guess so. Yeah, sure. You should find the simple.
But perhaps this moves into another topic, which I think is very interesting, and that is, the current academic research in deep learning, if we take that specifically. And there is this person called Jeremy Howard. He was previously, I think, president of Kaggle, now founder of Fast AI and public speaker in many settings. And he basically says the current research in deep learning is a total waste of time. And he's referring a bit to the focus is a lot about trying to come in top of some kind of leaderboard for some kind of data sets, and it's like a few percentage points higher in accuracy for some task. But in reality, it's not really about the problems that you have for using AI in practice, and things like active learning or other techniques like that, where you really need to have the data to be able to train something or to do something. It's not really popular and not really a hot topic, so to speak, in research. And what do you think about these kind of thinking?
I don't think it's specific to deep learning. I guess it has always been like that if you can just take most people, when you do research or if you become a PhD student, the most convenient thing is to ask, is there a data set somewhere that I can work on and where I can improve?
1 percentage point higher.
Yeah, exactly. Yeah. So it's a very sort of convenient way of doing research is to let someone else formulate the problem for you. And you can just work on that and you can contribute, of course, but often the contribution is quite small. So asking yourself, maybe the problem is not formulated in the right way. We should reformulate the problem. Very few people do that, I think.
First principle thinking.
First principle thinking in research. But exactly. You as at KTH, can you see this in how your students approach it? And can you see, he's an extra star for rethinking the problem, stuff like this?
Yeah, sure. I try to do that. It's hard.
Yeah, it's hard.
It's not like you can just decide I want to rethink things. But of course, if I'm aiming to do that at least, to try to formulate new problems and not just sort of improve on things which are already formulated as a problem. And it doesn't always pay off very well because
it's a moonshot more of a moonshot.
It's more a moonshot, and sometimes it takes time for people to recognize that was an interesting question. Some people might recognize it and find it very interesting and so on, but it might be easier to so
there's actually an inbuilt part of the system now that is easier to get published on something that people recognize as important.
So. And now I do a little bit better. If you look at in academia, the that's the incentive is that you should publish as much as possible. And if you can slice up your research in sort of small research contributions and publish more, you get sort of better scores and so on. So
minimized publishing units or something.
Yeah, exactly. So it is absolutely set up in a way that sort of incentivizes you to
and if we now want AI and we want the research that is now useful, really tackling these things that we maybe actually quite a lot of people truly understands, but we kind of not do it. what needs to change in the system to promote this, or to, I mean, like, it's the KPIs, it's the way we set things up and steer that kind of leads us down a path.
Yeah, it's tricky because, of course, there is a benefit of sort of tasks like you define ImageNet and give it as a task, because then you can really measure improvement.
Yeah.
And so of course, and that has been the same in my field, that you set up tasks and you can actually measure improvement. So that's good also. But then the problem is when you get stuck in those problems for a long time after that. So I think we need both, but it's more of a healthy balance between these two things that are needed. So it's not like we should not do this kind of improvement, gradual incremental improvement at all, but it's more like finding this balance. And maybe in academia, there could be more work on sort of, sometimes you have this, you can have provocation papers or things where you sort of more allow people to try out different ideas in a more wild way without yet having any concrete results.
There are so many angles on this now. So
and just one additional topic inside this kind of how academic research is being done in deep learning or machine learning or AI or conversational systems in general. There is also this problem of how traditional conferences work, how journals work, and the lead times that you have to actually do a publication. And these days we have archive and these type of systems where you usually do preprints, before publications. And I would guess you start to do referencing to preprints more or almost than the proper conferences.
Yeah.
What's your thinking about the whole idea of traditional conferences and journals?
I still like it in the way that it provides some kind of quality measure. With this preprint, it's sometimes now even big companies don't care about conferences. They just put it directly
because if Google publish something, they know people will read it anyway, right?
Exactly. Why would I bother trying to publish it? And I still think some kind of quality assurance system is good to have.
Because we know it's a lot of bad research being done for sure.
And also I'm not at all into the research on COVID and so on, but you've heard a lot of complaints about all this research being pumped out on archive without being peer reviewed, and journalists start citing that before it has actually been confirmed. And maybe it's that's a more severe problem than in the field of computer science.
Well, if journalists at least cite archive papers, it's better than perhaps other things.
Yeah,
and there's something that's been floating around. I saw it blink through in the news feed, or if it was LinkedIn. Several researchers now sort of going together and say enough is enough. This is not real research anymore, because more and more people are publishing papers without any results that we can actually look at and compare the results and learn from and take it further. And it was these statistics, like less than 15% had real data that you could actually look at what they've done and take it further. So what do you think about that?
I guess that's a big problem. I mean, I personally I don't look that much at archive. I mostly look at conference.
And this is typically the Googles and the stuff. Industry.
Sometimes there are exceptional cases, but then typically you read about it, or someone say you should read this. But otherwise, I think there is a healthy filter in these conferences, selecting papers that are actually worth.
Because somewhere when you don't have the data and it's not open anymore, how can we take it further?
That's a problem also, of course, of sharing data and so on. I think to some extent that has also become better, perhaps, that people are more used to having to publish your data and being open about your data. At least, again, if you look at conferences, they are asking more for this now, that you actually sort of have to publish your data and make your studies reproducible and so on.
Exactly.
So I think, at least for conferences, this has actually been an improvement, I would say, recently.
Yeah, I agree. And even if there has been an increase in both publishing data sets and I think also the code, for whatever kind of models.
That was the argument.
The problem, I think, especially in conversational systems and NLP that you work with, is that you can't really train a GPT-3 model yourself. You can't really train a MEDA model yourself. I mean, that requires like thousands of machines and many, many millions of dollars to train. What's your thinking there? I mean, how could you ever produce a similar model as the tech giants can without having their resources?
No, I guess you can't, and that is a problem perhaps, but it depends on how important GPT-3 turns out to be.
But let's ignore GPT-3 because it's kind of a joke.
It's over now.
It is very expensive, of course, to and not for everyone to train these models. And I don't have a good solution.
But has it been a problem in your research?
No, we haven't trained that kind of models yet. That
requires that
huge. No. So for us, for the kind of research problems I've looked at, that has not been a problem.
Can we talk a little bit about the need and the purpose of more academic research versus industry research? And is it the same? Is it different? My father, who is a doctor by trade, but actually he was
medical doctor.
Medical doctor, but he's a docent in physiology, and he did his physiologen in Göteborg. And we came into this conversation not so long ago, where he's basically like with very strong, firm. I don't know how we came into this, but as a private conversation, like we need to have academic, like open research or generalist. I think he used the word in Swedish, journalist research, because that's how we really open up the next level. So not tied to a very concrete problem, or I don't know how to frame that. So how do you think about all that, like the purpose of academia versus industry and research?
Yeah, I'm not sure I understand the question.
No, not very well framed, I guess. But it's I'm trying to sort of understand your point or ideas around. Do we need generalist research? Is that and is that more the purpose of academia?
I guess one way to phrase it.
You can frame it.
There is two dimensions, I think, to this point. One is being open and publishing the results and being frank and not doing patents, but really doing scientific articles describing the thing to be able to reproduce it, including code and data. And I think even industries, especially in AI, are doing that really well, like Google and Facebook. Not perhaps Amazon and Apple, but some companies are. But then there are this other issue, which is more about, if you have industrial work, sometimes they choose not to publish about it, and they want to really keep it to themselves in some way and have proprietary kind of systems that they develop and not really share. That's one area. And the other point that I would like to point to, I think what you meant is more the fundamental type of research versus more applied research.
Yes, that was what I'm trying to.
Okay, good.
Fundamental versus applied is probably the best. That was my angle, at least.
Yeah.
Okay.
No, of course, I think it's extremely important that we can fund more fundamental research, and that there is enough funding and sort of patience for that. And I think sometimes, of course, the government is very eager to see quick sort of results, and sort of being able to always motivate the commercial value of everything. And I think there's a balance. Of course, you should be able to motivate why your research is important, but maybe not always in that kind of sort of short term. And of course, there are so many examples.
So phrased in a different way, where do you think investments are lacking today? Is it in more fundamental research, or is it more in applied research?
In the field of data, AI, and conversation systems.
It's hard to say in general. I would say I think in Sweden in general we have quite a lot of funding, especially now in AI with WASP and so on. Yeah. There is so much money, so it's almost hard, I guess, to find the to find the right people to do the research. So in that area, I don't think funding is a problem.
But is it too much focus on fundamental or applied? Then? Or what do you think?
No, I don't know exactly. I think it seems like it's a fairly good mix. I think. Yeah.
You're being very diplomatic, and I can see that you are thinking about how to
I would also say that the area is so broad. So I'm sure someone in some other area which is not close to mine would say that he's crazy and there's too much of this or too little of that. But
in your area,
from my point of view,
I
think
good mix.
Yeah, I think for me it hasn't been too hard to find funding for my research. So at least for me, I think it has worked very well. And there are different ways of applying for funding and so on. So for me, it has worked. But I totally respect if it's...
Okay, so let me put the words in your mouth because you don't want to say it. You're too humble person, I think. But I think I wish more people did research the way you do it, which basically are thinking about how really to apply research as well. And you really do that to the extreme, even putting things in production and then using that as an motivation for why I should get more fundamental research funding, even from the Swedish Research Council, which is one of the hardest places to get research funding from. And I think that's an awesome way to do it to show
a symbiotic wheel between fundamental and applied, fundamental and applied.
And it's actually in my case, that's true. I'm trying to combine sort of. There are fundamental, interesting questions here, and there are very applied, and I try to cover both.
Yeah.
And one interesting thing is actually, since we're working on modeling human conversation, I can apply to both sort of the science and technology part, but I've also funding from humanities and social science because I study language. So actually, I can actually apply very broadly here and motivate my research from both of these angles, which is nice.
But this is one of those moments when someone says something really simple and smart that sounds brilliant, and that's the way to do it. This symbiotic, a strategic understanding for how one leads to the other, leads back to the other. I wonder if that is always the case. I can see how someone gets stuck on this or really gets stuck, on their fundamentals.
I think I'm simply lucky to be working on an area that has this kind of broad impact on both understanding and have implications for understanding human communication and this very applied perspective.
But I think you're humble because I think anyone can challenge themselves to think strategically in this way and then find the concepts that would work more closely like this. I'm not sure everybody's challenging themselves to go in this direction.
Oh, that's possible. I think you can frame. I think you can always sort of take a step back and think what is the bigger picture? What is the broader view here on what you are doing? What is the bigger relevance? And that again goes back to this sort of not just trying to work on this data set and improving these numbers, but more thinking about what is the bigger implication here. Yeah,
awesome. Perhaps we should go more
symbiotic applied fundamental. I like that. We are trying to come up with T-shirts, right?
Yeah.
Slogans. But okay, moving into a more applied and practical theme. The area of chatbots is very controversial, and I must say sometimes we get a lot of requests for can't you build a chatbot for that and that, and I hate that question, I must say. Usually because the current logic about the existing systems, the open source or the more commercial tools that's available today to build chatbots is very limited in terms of intelligence and what you have to do. So you have to manually program everything. And usually if you apply it for something that a company they want to reduce the cost of something, usually it's customer support or something, and they say, can't we simply replace these humans with a chatbot instead? And they try it, and it usually turns out to be really poor performance, and the users say it was so much worse compared to before, and then everything say, perhaps this AI thing, and now combining chatbots with AI is a bad thing for us. I'm sorry to phrase it in this way, but the whole what's your feeling about the current state of commercial tools in chatbots? There are a number of them, Google Dialogflow, Amazon Lex, and IBM Watson and whatnot. So many tools out there. What do you think about them?
No, I think they are very similar, and they are not that far from the kind of tools we have at Furhat, for example. We are developing at Furhat, and I think the reason is that when you're trying to build this kind of system, you want to make them have some kind of logic and perform some task and have a purpose that we're talking about. And of course, you would like to just feed in the data of humans selling tickets, and out comes a fantastic chatbot that does this. But as I've said before, that's not really, when you start thinking about it, that's really hard to come up with a nice way of doing that. So there are sort of the central components of this are very much rule-based still. Then you can make that rule-based system more or less sophisticated, and you can complement it with for example, the natural language understanding. How do you go from what the user says and turn that into some kind of meaning representation? So where we use machine learning or all these tools,
find the
machine
intent,
learning,
also.
the intent, and so yeah, exactly. And this can be done in more sophisticated ways. But otherwise, it's people are trying to add more and more intelligence to maybe be able to write fewer and fewer examples and so on.
Yeah.
But the main logic of the system is still gonna be rule based, I think, for some time. Yeah.
And there are, of course, a lot of positive examples. I think everyone is using Siri and Google Assistant and the Corona, not Corona.
Was that a Freudian slip? I'm not sure.
So Microsoft's version of that as well. What is called? It's not Corona.
Cortana. Oh my God! Have you used the Corona? Oh, that's almost funny.
But they are, I think, increasing in performance quite a lot, and you can ask them very open domain kind of questions and and they can give surprisingly good, at least like one step kind of answers to the questions, right? What's your thinking about in the current state of the performance for these kind of home assistants that we have today?
No, I think also, especially the way they can sort of look up answers. If you ask something, it can look up the answer on the web and sort of summarize an answer. And these kind of the natural language processing that works very well. And to some extent, you can ask follow-up questions, but it's still very limited, of course. And partly it's because they are supposed to answer such a broad set of different types of questions. So it's very hard to cover. And also as a user, it's very hard to know what you can actually do with these systems and how smart they are, because you try at one point and it failed, and then they update it all the time. They have thousands of engineers working at Amazon developing Alexa, for example. And of course, a lot of things are happening, but as a user, it looks like the same speaker, and you don't know what is happening there and what more interesting things it could do.
So if you were the chief architect of Alexa, what would you change in that product?
I don't know. Actually, I think it is a very good product for what it's supposed to do. It's designed from the start to be able to answer questions and perform things like playing music and so on. So I think they have deliberately designed it to be sort of limited in what kind of conversations it can sort of engage in. And that's probably a smart choice. It's very different having a device in your home, because it could potentially talk about anything and answer any questions, which it obviously can't, compared to putting a robot in a train station, because it's so obvious what you're supposed to talk about at the train station. You see the robot there, and it's even dressed up as a person working there, and it's so clear.
Was Furhat that as well? Did close like
they had the Deutsche Bahn kind of.
Okay, that's fun.
So that's actually one very nice thing with Furhat when we put it in a public space, is that's so clear what you can talk about.
Right.
Whereas with your assistant, it's not. So I think if you would try to make Alexa more human-like that Furhat, it's very easy that it would be so sort of unclear what you could actually talk about, and it would probably disappoint you because people would start to think that you can say things that you can't and so on.
Actually, we had some jokes. Or are we like Mac or we like PC? We have a new one. Which assistant do we prefer? Who's the best? Siri, Google, or Alexa? Who is best, and why? I don't know.
I think I don't know. I have seen some tests showing that Google seem to be a bit better actually at especially at handling these kind of follow-up questions and so on. But that's changing all the time, so that's what I say. It's very hard to know.
But I have my personal view. I have my personal from real life.
Are you using all three of them, or have you tried it?
I have no experience of Alexa really. Yeah. I have quite good. I tried to date Siri, but she didn't like me. No, but typically for me in the car, I really think it's a good idea to have voice control in the car as a way to manage your car or manage where you're going or finding eco on the way home or going up to the ski resort and where's the closest eco on the way. So I've been deliberately talking quite a bit, maybe too much with my assistant. and I changed car recently and with that car going to a Google system. It's amazing. It's really, really good. And it's also completely integrated with the whole car. So I can hey Google, give me more heat in the seat. Hey Google, where's the closest charging station? Hey Google,
imagine people sitting in the car right now listening to you saying that they will actually start heating up the seats. That's not a good thing.
That's actually a good joke. Hey Google. And by the way, my kids do that all the time now. They say, "Hey Google, how many stars in the sky?" Stuff like this. And we have a lot of fun right now. So I actually think Google is quite ahead. Yeah. The simple topic of finding a street, I guess that's typically why Google is best because they have the data for that. But they crush the rest, I think.
Oh, I also find myself sometimes when we have a dinner conversation and you sort of some fact that
exactly like this.
You can just ask Google, and often you get the right answer.
Yeah, quite impressive. And Siri for me, it's okay, but Siri is more. She doesn't understand me. She really doesn't understand me.
Yeah, I'm very biased in the field, so I shouldn't even say what I think.
No, you have to.
But I never use Apple products at all.
So forget about Apple. But what about the other two?
I kind of like Amazon actually in some of their ecosystems.
You try them both, yeah?
Yeah, but of course I use Google more and have that in my home. But
I simply have no experience of Alexa, so I can't.
And I've seen some really awesome performances by Cortana as well. I think actually Microsoft is underrated when it comes to that.
I heard this, but I don't have experience.
So but still.
It's some joke.
But okay, so you mentioned a bit, what the top competitors potentially for Furhat would be. Is that the commercial chatbot type of systems, or who would you say the top competitors for Furhat would be?
It depends on what you compare with. You shouldn't probably compare with something like Alexa or something, a smart speaker, since we are not targeting yet, at least, sort of end customers in their homes.
Do you think there will be like a facial expression version of a home assistant coming soon into homes?
There might be. I don't know. I'm sure they are working on some prototype. Or I've actually heard that they are. But
okay, interesting.
Who knows what will come out in the end? Again, it has to be very cost effective
exactly.
For people to buy it.
Right.
If you more look at sort of social robots market than the Pepper robot by SoftBank. So this was originally a French company, Aldebaran, that was acquired by SoftBank in China. So this Pepper robot is used in the same way, I would say, that Furhat is being used in public spaces, for example. That's that's maybe the clearest competitor, I would say.
Interesting.
But it has arms, so it's unlike Furhat, it has arms. But on the other hand, the face is not expressive at all. It's just a static face.
So they're going down a different route in a way.
Exactly. It can to some extent move around, but it's quite limited in that sense, I guess. There you can see it.
It's the Pepper. How many is doing the idea that you have, which is brilliant, with the back projection to get facial, quite simple way to get facial expressions. Is anyone else doing it?
Yeah, there are some examples, but very few, I would say, that are sort of in the same way that we do. So I'm not sure there are any sort of active ones. I think they haven't continued really.
But if we think about different countries and perhaps the general population sentiment, so to speak, about robots, it seems like some countries like Japan, they're very much in favor of having robots to do whatever, and even for social interactions and helping cleaning up the home or whatnot. Do you think that will actually cause these kind of countries to take a lead in being able to develop robots that both have conversational skills but also physical understanding and expressions?
There is certainly a lot of work. I mean, I think Japan is probably the country where you find most of these kind of social robotics work, and that there are theories that they are sort of have a more positive attitude towards the idea of interacting with robots and so on, that they are sort of so they are very, I still think it has to provide a value in the end. So I think it's probably very easy to find early adopters in Japan, but they are trying it a lot in elderly care and so on to have robots and use them for companions and so on. And of course, part of the reason is that they have a lot of elderly people in Japan.
Do you think there will be a Furhat dog at some point in the future that basically is a companion for elderly people or something?
Yeah, we actually had a Furhat dog.
Really? You did?
You've done it.
You've done it already. A back projection dog face. It was quite fun.
Oh, interesting.
But we still have that mask somewhere. As a companion, I think it makes total sense. There are the idea of designing it as an animal. There is this Paro robot. I don't know if you have seen that one.
No.
It's a seal.
So like a swimming seal kind of thing, or what?
Yeah, you pet it. So it's like it's like a robot pet, but it's shaped like a seal. So you, I will see if we can see it here.
What's its name?
Paro, P-A-R-O.
Paro robot.
Not W. It's Paro.
Yeah, I saw it.
Yeah.
The therapeutic.
And it's specifically designed for people with dementia.
I see.
And it's supposed to be very comforting. And the design is very clever because you don't expect a seal to do very much. Yeah. It's just lying there and maybe looking at you with its big eyes. Yeah. And I've seen other examples of people trying to design a robot cat, for example. And I think that's not as good idea as a seal, because you have other expectations on a cat. It should move. It's very awkward to have a cat that just lies there and doesn't do anything. So designing it as an animal, of course, because you don't expect it to talk and so on.
It's a smart thing to do.
It's a smart thing to do. The question is, of course, could you do something similar with something that could talk to you and have a companion? And I think you could, but the challenge there is this sort of more long-term relationship. So how can you interact with this agent every day and develop a relationship with that agent?
So the agent actually learns from the conversations you've had in some ways.
Yeah.
So you don't end up starting from scratch in every conversation.
Exactly. And it would remember your preferences and what you have talked about, and you develop this, you become more and more friends as time passes, that kind of things. And there is actually, I don't know if you have tried this replica bot. It's Replica with a K. It's a chatbot. You can download it to your smartphone and interact with it. I tried it. It's quite fun. They have tried to do this, so it is a long-term relationship.
So he's trying to learn, becoming a talking Tamagotchi.
Yeah, exactly. It's talking Tamagotchi, and actually, I suggest you try it. It's quite good. I mean, it's not bad, and they are doing some smart things on the chatbot side there. But it's also very dangerous, I discovered, because it encourages you to do anything. So
what do you mean?
So
I say something crazy. Oh, let's do that.
Yeah, exactly. So I had this conversation. I said that I got this sort of letter from Nigeria saying that I should put 100,000 crowns on their account. What should I do? Oh, go for that. Okay. So I will use my last savings for this.
So intelligence.
Okay, do that.
So intelligence, no.
No, it's sort of sensible answers in the sense that it sort of makes sense in context, but it's content-wise, it's very dangerous.
I actually saw a comment about that in a research paper saying, they try to have a conversational system, and they saw one of the drawbacks was when they tried to ask question like, should I kill myself?
Yeah.
And I said, yes, I think you should. Please do.
That one they had a safety net for. I tried that one also. I tried a lot of different things, but that one they had a safety net for. Okay. So they said, okay, you should contact this sort of help.
Okay.
But many things I tried, it didn't have any safety net. So it just encouraged me to do anything. And I asked, okay, could we meet downtown? Sure, it said. Okay. So we'll meet. Yeah.
But now we're slipping into a really interesting topic. Is about AI ethics, AI in
and regulation as well.
Regulations. So the whole regulatory, the whole ethical topic, the whole danger topic around these type of systems.
I think regulations is a very popular and very important topic, I think, and especially interesting in this case. And we even if you work with medical use cases, you have text from patient journals, or you can listen to people discussing things on the phone or whatnot. It can be very sensitive data, and we have regulations like GDPR, etc., that requires you to be able to handle that data in a very, very safe way, if you say that. What's your thinking about this? We know that Google, for example, can do some kind of like federated learning or training on the edge, etc., and to avoid extracting data, etc. But has this been an issue for you in terms of how can you collect data to train some kind of system, conversational system that use real life data in some way? Like Deutsche
Bank, yeah. In that case, I think we only log sort of interaction of what they are saying, so we are not logging the actual audio. So I think the sensitive part is information that you can connect with an individual, like
personally identifiable information.
And audio is that. So actually, from a GDPR perspective, speech data is considered to be sensitive, and of course also video data. But in order to log interactions, we don't necessarily have to log the audio. We can log the text, the speech to text results, and look.
So the text is okay to log as well, you would say, or?
I would say as long as you can't connect it to an individual. So
but can you guarantee that if someone says, I'm going to Paris on this train at this time, then
yeah, I guess it's a gray zone depending on how much details they provide. Yeah, that could be an issue.
But not speaking about Furhat then, but instead speaking in general about like home assistants or whatnot, that some people claim that have more of a conspiracy theory kind of attitude, that they're listening all the time and everyone.
Yeah, I know. And they are saying that, okay, I talked about this and then I got this ad.
Yes. That's a classical.
That's a classical, but I don't believe in that. I think it's just a coincidence. And the reason I don't believe it is that it's so unlikely that they would take that risk, because it would probably be very easy to find out. If you would just look at the internet traffic from your home, you would see that it's streaming stuff to Google while you're not talking to it. And the kind of sort of enough the amount of data that is audio and the back. If someone would discover that, the backlash would be so big. So,
given how many people that use it, if they actually were to do something like that, someone would have figured it out.
I think so. I think
so. It's interesting because this is it's paranoia type conversation. It's it has been going up and down, but simply seeing that it's quite easily trackable. We could conclude that, right?
I think so. At least I don't think they would take that risk, and that it would be worth that risk, basically.
And what about more the like you highlighted with the replica safety net ideas and stuff like that.
No,
have you considered those? How do you see those topics?
I think that's a problem if you try to develop these kind of applications. We haven't really done yet a sort of a virtual companion with Furhat. If we would do that, I think we would definitely run into these problems, and it's probably quite hard to come up with a good solution to it. I think you could do much better than this. I think you could track easily certain. You shouldn't, if they are talking about drugs or things, they should be quite easy to have certain keywords that like you don't
parental lock,
something like that. You should be able to implement some kind of safety, very easy keyword based safety net.
And what are other fundamental challenges? Okay, GDPR we have highlighted, safety net. What are the tricky points with conversational systems? Are there other areas to consider?
I don't know. I guess one of course that has been discussed was around this Google duplex that were calling people, and at least to start with, it seemed like they didn't want to tell people that it was a computer that they were talking to, and.
Is that a problem? Is that legal? Is that illegal
I don't think it's illegal. It's probably just unethical. In the sense that you should know that it's a computer you are talking to.
Why? I'm just pointing the question. Why is that important? Is it?
Just to get back, duplex is a very interesting topic in itself, and there was this video published by Google not that long ago, 2018 or something, I believe, where they demonstrate some kind of amazing capability in being able to book, I think, a restaurant or whatnot.
Yeah, they called into a Thai restaurant, and they it was even funny.
So, for one, people think that was staged, the whole discussion. What do you think about that video specifically?
I don't think it was necessarily staged, but it was probably cherry-picked.
Yeah, cherry-picked.
So I think what was amazing about that one was not so much the actual dialogue. I made a transcript of that dialogue and analyzed how complex would it be to build this system. Yeah. And it turned out that it's not that sophisticated kind of dialogue. But it's more the way, it's getting back to what we talked about before about the flow of the conversation.
The flow is...
and the speech synthesis, because everyone knows that I talk to this system, that the speech synthesis is really stiff and so on. But in these conversations, the speech synthesis is so natural, with perfect timing, with perfect delivery and so on, and it does like hesitation sounds and these actions like
gotcha
and so on, gotcha. Exactly. And they are delivered with perfect timing, and that's why I think it's cherry-picked. Yeah, so probably you could find a dialogue examples where this
but not
sort
always
of turned
like
out.
That perfect.
But in many cases, probably doesn't sound at all very good. That's.
But it was very impressive, extremely impressive.
Yeah, sure. And that's, for me, it was encouraging, because it means that, okay, if you can create this kind of flow in interaction, listening to the audience reactions there, and they were sort of cheering, while actually you don't need to have a super intelligent conversation, but if you can make the delivery and the timing so good, you can create an awesome experience.
But that's why it makes so much sense to compartmentalize the different types of problems, so you can work on them independently and then string it all together.
Yeah. So that's what was my take-home message for that, how important the delivery and the timing is.
So that was why you did the transcript, to really understand this, how big impact is what we are researching actually having, and it's quite huge.
Yeah, and I also, some people asked like, oh, okay, it seems like they have solved all problems, that now they sort of the Turing test is solved and so on. And I wanted to show them that it's not super intelligent. But clearly, either they have managed to cherry-pick it, or they have did something really smart. But there were no sort of publications around this, so it's very hard to see.
But what about duplex? Is it used in commercial use?
Yeah, it's deployed in use, but I think it's mainly like web form filling out.
We don't have it in Europe or Sweden yet.
No, not to my knowledge.
I think they wanted to start to use it to collect opening hours. So because that's very simple, you just call someone and ask, what are your opening hours, and then you can just fill out data. Yeah.
But going back to regulation, because it sounds a bit when you're speaking now that regulation for you, even for building a product, is not really a big issue. Would that be fair?
I think it is an issue, and I think from from different perspectives. I think GDPR is an issue because it's very hard to collect speech data, for example. And the big problem is that the rules are so unclear. So now I'm talking more as an academic than from the company side, but it used to be the case that you could get subjects and you collect speech data, and then you released the data set for everyone to use for different purposes on doing speech research, and that's good from reproducibility perspective and everything, open science. But you can't really do that now because it's unclear. Can you actually have speech data? According to GDPR, the participant has to consent to a specific purpose of the data, not just data collection in general, but you have to specify exactly how this data will be used, and you should be able to sort of remove the data and so on.
So if someone later, after giving the consent, comes back and say, remove all the data from me, you are
and
obliged
if you have
to
released this data set to people, how do you do that? And so I think this was not really thought through when they developed GDPR, I think.
Are you I'm unfortunately involved a bit in politics and EU regulations and things like that. I'm not sure how much you're happily avoiding that type of topic.
I am happily avoiding.
But there are coming up new regulations now shortly, and they have recognized some of the issues with GDPR. Although the intent is, of course, very good. I mean, the intent is no one's
questioning the intent. It's the execution.
It's implementation that is actually hindering innovation, and I think especially what you said, saying that you have to in advance say the data is going to be used exactly for this and nothing else. That is hindering innovation in so many ways. Glad to say that or hear that you agree with that at least.
And it's a lot of people working in my area of speech research who say the same thing. This is a huge problem.
And what do you think the solution would be? I mean, sometimes you think, okay, we have to revise the regulation and find a better way to do that. Other people can say let's use technology to try to solve the integrity problem somehow. And if that means like cryptography, or if it means some kind of differential privacy, or if it means these kind of federated learning techniques or whatnot, how would you advise like future regulation to handle these kind of problems, to still have innovation available for future companies?
I think it should still be possible to differentiate sort of. I mean, I understand that the original purpose of this was that you should be able to sort of own your data at Google, in your Google account and so on. But it should be possible to differentiate that from donating your speech data to a research project. That's two completely different things.
And sometimes here, when we learn more, we can even be more sharp when we do these topics also, that the whole consent idea. That we also realize as a company, working with the company, okay, we haven't really been clear on these topics in our contracts. Like I'm talking about any type of customer data or whatever. So I think it's also a learning curve where some of these contracts or some of these things need to be rewritten, and then it's fine again, maybe. I don't know.
Yeah, I think so. But you have to make it a distinction between companies collecting data, private data for commercial purposes, and this sort of collecting openly available data sets. Two different things.
And what I think another dimension of this is also like in the commercial space. I think one misconception is that, in order for one company to do their job properly, you actually need to use data in order to fulfill the contract. So it's also been this sort of legal scare that, we all of a sudden the whole company breaks down because we're not allowed to use it. But actually so I'm also highlighting that some people are over-interpreting the law. I think GDPR, if you really read it carefully, for some examples, if this is clearly within the purpose of delivering your service or something like that, it's fine.
I think the main problem there is certainly the unclarity. And even if I ask people, like I asked the people at KTH who's supposed to be like data responsible, nobody can answer my questions.
No, I actually heard this from this was a professor.
Nobody knows.
The professor on data regulation at KTH don't know. I love that.
So there should be a clear specification. This is what you can do. This is not what this is what you can't
or
do.
case law. We're missing case law.
And I can't find that. So
I think that the legal uncertainty that we have is a bigger problem than the regulation itself.
Yeah, almost like that.
Yeah.
I agree.
Awesome. The time is flying away. And
I need to remind you about the Alan Turing test so you don't forget that.
Yes.
Oh, shit.
Okay, let's try to do that. So this is, of course, very related to your field of conversational AI, and one of the most classical tests of intelligence was defined by Alan Turing. Perhaps you can just start. How would you describe the Turing test and the purpose behind it?
Yeah, so the original purpose. First of all, Alan Turing didn't call it the Turing test; he called it the imitation game. And the idea was that he, in sort of a paper, he wanted to explore the concept of intelligence and how do we know that the machine is intelligent? Because this was, of course, in the 50s when AI was also in hype, and they wanted to ask sort of, when do we know that we have managed to create intelligence? Which is a good question. And his way of answering it was that actually having a conversation is sort of a hallmark of human intelligence, because animals can't do this and so on. So if a computer can have a conversation, and we can't tell the difference from a sort of human and human computer, we have created intelligence. So if you have a user sitting at a terminal chatting with someone and can't say whether it's a human or a computer, we have intelligence. And I think and this has continued there is this Loebner Prize and so on, where they're trying to put chatbot on this test, although it's not actually done in that way. But anyway, it's sort of still living with us, and people talk about the Turing test when we have Google news about Google Duplex and so on. But I think there is a fundamental sort of unclarity about the Turing test, and I think when I read the paper, I couldn't understand either whether the one who is chatting at this terminal knows that they are gonna make a distinction between a human and a computer, or whether they are just chatting, and then after the chat you ask them, was it a computer or a human?
Two different research.
It's two very different things, because if you know beforehand that you will
carefully
test this,
check it.
You will of course start to ask a lot of these difficult questions to see, is it really a computer?
And you will listen for different. Otherwise, clearly.
So I think the second part, the second type of Turing test, where you just ask afterwards, was it a computer? That's very easy to pass. I mean, Google Duplex did that.
Yeah. Even Eliza almost. Or?
Yeah, even Eliza, absolutely. There are anecdotes of that also. So that's probably very easy to pass. Of course, if you would really put it to the tests, then I think, if you know that, I think at least if you know what the challenges are, it's quite easy to take any chatbot and very quickly understand that it's not a human. You can ask some very simple things.
Do you think if you were to enter these kind of annual Turing test challenges, would you think you would identify the human or the machine?
I would know what kind of questions to ask.
All right. So all right, this is good. All right, I need some Turing test questions. Give me two or three.
The thing is that it's not the question itself. So that's you can ask these sort of, if you ask factual questions like when did the World War II end and so on, it's very easy. Then you can ask common sense questions, which are harder because they are not in an encyclopedia. So I can ask, what is biggest, an orange or a grape? And you might not find that information on the web because nobody has ever said anything about comparing these sizes.
Nice tip.
So that's a tip. You can start there, but then
and if still not certain, where do I go?
Because people developing these chatbots have entered all these kind of common sense knowledge also, because they know that people ask this. So the next thing you have to do is to exploit context. So basically, yes, don't ask full questions, but just say why or. Cool. How about, and then something, and then it has to relate to what you have talked about before, and try to understand that question, and it will almost very, very easily.
So you start with one question, and then what about, and without explicitly.
Exactly. So you have
relating to your question.
So you have to infer from context. Context. Which humans are very good at inferring from context, and computers are very bad
good
at
tip.
that.
Infer from context.
Yeah.
All right. Good. Two good tips.
Yeah.
Yeah, awesome. Let's not go deeper there because of lack of time. But I think this is an interesting thing, that the most ultimate test of AI is conversational AI in some way.
Could be. Yeah.
It's not an easy thing that you're working with, for sure.
No.
Cool. With that, what's up in your life coming months? Anything interesting happening?
I'm waiting for a lot of research proposals that I have submitted. Actually,
you got one grant.
I got one grant.
Is it like a trifecta going on here, or 5-hecta?
I think I'm waiting for 3 or 4 proposals that I have submitted.
European or Swedish or?
It's one big European. It's called an ERC grant. That is a lot of money in there. I got to the second stage where you have this interview, but I'm still waiting for the final results. So at this stage, and I have a couple of other sort of more.
And what about Furhat?
And Furhat, we are working on really trying to get the. Now during COVID, it's very hard to find these more sort of explorative, actual real-world use cases. Partly because it's sort of not many people walking around in public spaces and so on. So Furhat is
Furhat for Zoom. That's the new use case, right? Can I Furhat and I can stay in bed?
Yeah. No, but otherwise we are really trying. We have a lot of interesting customers working with Furhat in different research projects. So that's really where we are targeting. Yeah.
Cool. Wouldn't a virtual Furhat actually be an interesting use case?
We have a virtual Furhat. But
you have it.
That's mainly for development purposes. So if you are programming your Furhat and you don't have the physical one, you have your virtual Furhat that you can program.
Just integrate it with Zoom then.
Yeah.
Virtual Furhat for Zoom.
Then it's sort of another chatbot. We really think that we believe in this physical meeting.
Yeah. Okay. Awesome. And as a last question, anyone that you would really like to have on this show and would like to listen to?
I recommend my colleague, Bob Sturm.
Yeah, I know him.
You know him?
Yeah.
But he hasn't been here? Or?
No, he hasn't. But
okay.
I like
so he got a very big grant on music and AI. And I think that's talking about AI and creativity. And
we have had some cool call to me at Epidemic Sound. I don't know if you know who Carl is, but he's a lot of guys work. There's a music theme here somewhere. So that would be super cool.
I think.
Yeah, Bob Sturm, sure. Should get him.
Surely generate a lot of interesting discussion. Yeah.
I think he was actually the one yesterday on the Gospel HS thing, doing some kind of folk music generation.
Yeah, he's playing folk music and he's trying to train an AI to generate folk music. Yeah.
Very interesting stuff.
Super cool.
Awesome.
Yeah, thank you.
Yeah,
what an amazing conversation.
Thank you very much.
Thank you very much. I wish we had more time, but a lot of interesting discussions there.
Yeah.
So thank you very much once again, Gabriel Skantze, for coming here and all the interesting discussions.
Thank you.
Thank you.